So welcome students. In this chapter of methods of differentiation, we look at how to differentiate some complicated functions. So in the 11th class, you have already learned how to differentiate a function using the first principle, right? Using the first principle, using the product rule, using the quotient rule, and using the chain rule. These are the 4 topics that you have learned in your 11th class. First principle, and from first principle you get the differentiations of some basic functions, and once you have differentiations of all the basic functions, trigonometric functions, algebraic, logarithmic, and exponential functions, we have used these functions and we have studied the rules called product rule and quotient rule. That is, if you have a product of 2 functions and a ratio of 2 functions, how to differentiate the functions. We have seen the formulas for this, and we have also seen how to use chain rule. Chain rule is used for composite functions. So if you have any 2 basic functions or 3 basic functions, so how to differentiate the product of those functions, how to differentiate the ratio of these functions, and how to differentiate the composition of these functions. These are what we have learned in 11th class differentiation. Now we'll go to the differentiation of some advanced functions. So the first topic that we're going to cover in this chapter is differentiation of inverse trigonometric functions. So we have already studied inverse trigonometric functions: sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosecant inverse x, cot inverse x, secant inverse x. But we have not yet found the differentiations of these functions. So in the first principle also we have not derived these differentiations. Now what I first do is I give you the 6 formulas for the differentiations of inverse trigonometric functions, and then we'll try to find the logic behind those formulas. So d by dx of sine inverse x is equal to 1 by root of 1 minus x square, and d by dx of cos inverse x is equal to minus 1 by root of 1 minus x square. D by dx of tan inverse x is equal to 1 by 1 plus x square. D by dx of cot inverse x is equal to minus 1 by 1 plus x square. D by dx of secant inverse x is equal to 1 by mod x times root of x square minus 1. D by dx of cosecant inverse x is equal to minus 1 by mod x times root of x square minus 1. So these are the differentiations of the 6 inverse trigonometric functions. So better to remember these formulas by heart. So for sine inverse x, 1 by root of 1 minus x square, tan inverse x, 1 by 1 plus x square, secant inverse x, 1 by mod x times root of x square minus 1. And the other differentiations will be the same expressions with a negative sign. So root 1 minus x square, 1 plus x square, mod x into root of x square minus 1. So these are the 6 formulas of differentiations of inverse trigonometric functions. Now let us look at how these functions, how these formulas are obtained. So let us look at them with some examples. I will not derive all of them, I will derive few of them. So let us now look at the process in which you can differentiate any inverse function. So let us look at a general derivation and apply that general derivation to inverse trigonometric functions also. So let f of x and g of x be inverses of one another. So let there be 2 functions fx and gx which are inverses of one another. So this implies, can I say that f of g of x is equal to x? This is the definition of inverse functions, right? This is the definition of inverse function, that is f inverse of x is equal to x, or f of f inverse x is equal to x. This f and f inverse gets cancelled, so you get x is equal to x. So that is the definition of inverse functions. So if f and g are inverses of one another, f of g of x is equal to x. Now I'll use chain rule and differentiate both of these sides with respect to x. So if you differentiate f of g of x dash is equal to, what is the differentiation of x with respect to x? 1. So this implies, what is the formula for differentiation of f of g of x? F dash of g of x times g dash of x is equal to 1. This implies g dash of x is equal to 1 by f dash of g of x. This is a very important formula with respect to differentiation of inverse functions. So if g is the inverse of f, g dash of x is equal to 1 by f dash of g of x. G dash of x, that is the differentiation of the inverse function, is equal to 1 by f dash of g of x. So this is a formula which is very much important for competitive examinations. That is exams like JEE. This formula is not much useful for board exams. So you have to remember this if you are preparing for JEE or JEE Advanced, so on. So whenever you get questions on differentiations of inverse function, this is the formula which will be useful to you. So now let us try to apply this formula for inverse functions, and let us also do some questions on this formula. Let us see how this formula can be useful in solving some type of questions. So let us apply the process that you have learned for inverse trigonometric functions. We know that sine and sine inverse are inverse of one another. So sine of sine inverse x is equal to x. Now let us differentiate this with respect to x on both sides. So what is the differentiation of this? Sine of sine inverse x's differentiation is cos of sine inverse x, right? Sine of something, cos of something into the differentiation of sine inverse x is equal to x differentiation with respect to x is 1. This implies d by dx of sine inverse x is equal to 1 by cos of sine inverse x. So d by dx of sine inverse x is 1 by cos of sine inverse x. This is the actual formula, but it is different from the formula which we have given in the previous video. So let us try to convert this into the known formula. So what is sine inverse x? If you convert sine inverse x into cos inverse. In the inverse trigonometric functions part, we have seen how to convert one inverse trigonometric ratio into another inverse trigonometric ratio. So using triangle method, right? So if this is theta, theta is sine inverse x. Sine theta has to be equal to x. So the opposite side is x and the hypotenuse is 1. So now the adjacent side from Pythagoras theorem will be 1 minus x square, right? So sine inverse of x, opposite side by hypotenuse, is equal to 1 by cos of sine inverse x can be written as cos inverse of root of 1 minus x square. So cos and cos inverse gets cancelled. So you get 1 by root of 1 minus x square as the answer. So d by dx of sine inverse x is 1 by root of 1 minus x square. So this is the formula, right? So let us apply the same process for tan. So tan of tan inverse x is equal to x. To differentiate it on both sides, differentiation of tan of something is secant square of something times d by dx of tan inverse x is equal to 1. This implies d by dx of tan inverse x is equal to 1 by secant square of tan inverse x. So again, you have secant here. So let us try to convert tan inverse into secant inverse. So let us use the triangle method. Let this be theta. So if tan inverse x is equal to theta, tan theta has to be equal to x. That is x opposite side by adjacent side is equal to x. So x by 1. So the hypotenuse will be root of 1 plus x square, right, from the Pythagoras theorem. So secant square of tan inverse x is equal to 1 by secant square of tan inverse of opposite side by adjacent side is equal to secant inverse of hypotenuse by adjacent side. There is secant inverse of root of 1 plus x square. Secant and secant inverse gets cancelled, square and root gets cancelled, you get 1 by 1 plus x square as the answer. So d by dx of tan inverse x is equal to 1 by 1 plus x square. So this will be the differentiation of tan inverse x. So similarly, using the same process, you can derive the differentiations of any inverse functions.